Last little bit for this section is reference angles. Reference angles is an angle to make things a little bit easier or to relate it to other things that are a little easier. So let theta be an angle in standard position. Its reference angle is the angle or the acute angle. We're going to call it theta prime. And anytime you see like it's kind of like an apostrophe like that. So we'll say it's theta prime. It's formed by the terminal side of your angle and the horizontal axis, in other words, the x-axis. So for example, if you have an angle over here in quadrant 2, well, the angle measures here, but the reference angle is just going to be that smaller angle there. If it's in quadrant 3, it's just going to be that small angle there. If it's in quadrant 4, it's going to be the small angle there. So essentially, it's going to be some smaller angle that's between 0 and 90 degrees. So as we're working through these, the easiest ways to go about them is to take your angle. If it's in quadrant 2, you're going to do pi minus your angle. You're essentially figuring out what the difference is between the half circle pi and where you are. Or if you're talking about in degrees, it's going to be 180 minus your angle. In quadrant 3, it's going to be similar, but it's going to be your angle minus pi or your angle minus 180. In other words, like say, for example, well, I'm not going to get ahead of myself, but it's going to be the full angle minus the half circle. So you're just figuring out what that little sliver is. And then for the angles in quadrant 4, it's going to be 2 pi minus your angle, which is just going to give you that little sliver, or 360 minus your angle. So starting off with 300 degrees, well, 300 degrees is over here. If you were to draw 300 degrees, that would be in quadrant 4. So it'll be rotated over here. 300 degrees is about yay. So we're going to say right there. Is that a perfect graph or a perfect drawing of it? Absolutely not. But the way I know that it's 300 degrees is by labeling it. So we're really just figuring out what this smaller angle is in there. Oops, sorry, that's a shape. I didn't mean that. So the quickest way to go about it is just do 360 degrees, since we're in quadrant 4, minus 300, which gives us 60 degrees. So our reference angle is 60 degrees. So the size of, sorry, that got a little messy there. Let's try that again. The size of that small angle here is 60 degrees. It's an absolute size. Even though it's technically a rotation down, we're just going to keep them positive. So our reference angle is 60 degrees. I'm going to write that down as such. A reference angle equals 60 degrees. For letter B, I want you to try that one on your own. See if you can figure out what quadrant you're in to start, and then go from there. All right, negative 135 degrees. Let me draw a quick sketch of that. Negative angles mean you're starting on the positive x-axis and rotating clockwise. Now, kind of working through that step by step, clockwise, if I'm rotating down, this is negative 90 degrees, and then negative 135 is just, well, 45 degrees more. So our angle looks a little something like this. So that angle is negative 135 degrees. Now, putting this into context, there's a couple different ways you can do this. We're essentially looking for this angle here. This one you can kind of eyeball it. Well, really all of these you can kind of eyeball it. But what I'm going to do is I'm actually going to do 180 minus 135. Even though it's technically in the quadrant 3, we can kind of cheat and say 180 minus 135 because that angle is 45 degrees. So our reference angle on this one is 45 degrees. Put a box around them, you're done.